Are you looking for one powerful solution to handle all your business data and add AI features? That's exactly what Supabase does. In this video, I'll walk you through every component of Supabase, from its database that handles both your regular business data and AI data, to login systems that work with Google, Facebook, and other popular login providers, plus monitoring and analytics, so you know how the system performs and how your users are actually interacting with your services. You'll learn how to build this system on an affordable cloud server, save thousands of dollars in development and infrastructure costs, and get your business ready for AI growth. This video is for you if you want to use the latest technology without going broke. Hello there, my name is Bogdan, and for those who don't know me yet, I'm a technology veteran with over 20 years of experience in the IT development space. Throughout my career, I worked across multiple industries on many roles, from business analyst and solution architect to developer, team leader, and project manager. For the past year, I've been helping businesses use AI to save money and grow faster. Here's what we'll cover. First, I'll explain every Supabase component and what it does. PostgreSQL with PG Vector for embeddings, Supervisor, Kong, Go Through, Postgres, Real-Time, Storage, Studio, Image Proxy, Edge Runtime, Analytics, and Vector. What you'll learn, what each service does, how much compute power they need, and which ones are must-haves for your specific business, so you'll be able to choose which ones to install and use. Why Supabase works as both a regular database with your changing business data like product inventory and pricing, and an AI database, so you can build apps that use your business data and AI together without paying for separate services. You'll get a complete setup guide including how to install everything step by step on an affordable and performant cloud server, how to make it fast and secure with Nginx, and how to access all your services once they are running. I'll give you very specific and working tips on how to properly set up Supabase, so you don't have to spend the time I did in finding solutions for tricky problems not covered even by the official Supabase documentation. Whether you're new to AI or want to improve what you have, this video gives you the complete plan to set up Supabase as your business tech foundation. Okay, so first things first. Let's have a quick overview of what Supabase is. We will cover what each component does, how to configure it. So at the end of the video, you can decide for yourself which exactly service you need. Supabase is just a suite of open source components. It's the equivalent of Google's Firebase. As Supabase is maintained by the open source community, you can self-host it and use it for free. What makes Supabase so powerful? The main advantage of using Supabase is that it will save you a lot of time and money in developing and deploying applications. It provides out of the bat the functionalities any modern businesses need to run. Most of the important components of Supabase are its database, its PostgreSQL database. The Postgre version of Supabase comes also pre-built with PG Vector, which is an extension that allows you to store also AI vector embeddings, allowing you to have in the same table both traditional classical SQL data and vector embeddings. Supabase also provides quick access to its database records via an API interface, meaning you don't have to create another application layer that exposes your data. This is already built in and provided by Supabase. Also, the account management part of a modern application is handled out of the box. Basically, any account management like account creation via username and password, email validation, password reset. You can also delegate the authentication part to well-known authenticators such as Google, Facebook, Twitter, and many others. Security, of course, is handled by Supabase. You can restrict and fine-grain your application usage via API gateways and even can control database access on a raw level. You can also add very quick new functionalities with serverless functions. This is an equivalent of Lambda from AWS that basically you can create the functionality you need for certain use case, but you don't have to develop the server, the application server that will host and run the code for you. This is done automatically by Supabase, so you don't have to pay for a team of developers to create this application layer for you. Of course, you have analytics engine that you can track and monitor how your Supabase is performing and how your users are actually using your applications. What we'll cover on each component of Supabase, a brief description. We'll specify whether it's mandatory or not, meaning you can opt to not install it or not, and how much system resources are required by the component. I'll take into account an average load for a small or medium business. Okay, so now let's go into the details of each component. So you have the PostgreSQL. This is the core database where all your data is being stored. It is being used and trusted by over 30 years by businesses all over the world. And as I mentioned, you can store within traditional SQL data that is changing all the time, alongside with vector embeddings, so you can integrate easily AI logic into your existing data. You have extra security with access control that you can delegate to specific users and roles, and you can also have it even more restrictive by having a row level security giving access to specific rows in a certain table. As you might have guessed it, this is the core database component, so you cannot opt in to disable it. As for the system resources, you need around 4 or 8 gigabytes of RAM, 2 or 4 cores of CPU, and I recommend at least 100 gigabytes of storage. Supervisor is the database connection manager. What Supervisor actually does, it keeps a pool of connections already open to the database and then automatically switches these connections and allocates them to new incoming requests. So basically, when a new user is trying to access the database, an existing connection to the database will be allocated to that user and not a new database connection created, because these database connection requests and allocation of resources take time. This is an optional service, but if you have multiple users accessing your database and many users are logging on and logging in, or you have different concurrent users accessing the database, then I would recommend to have this installed as well. As for resources, you need around 1 gigabyte of RAM and 1 or 2 CPU cores. Kong is the API gateway. This is the main entry point for all client requests. So it acts like a gatekeeper for all the API traffic coming to all your Supabase services. You can set it up to configure API gateways and routes, and you can use it to enforce authentication. You can have rate limiting and policy enforcements across your services. As this is the main orchestrator for the Supabase services, This is mandatory, so you must install it and run it. As for resources, you need 1 or 2 gigabytes of RAM and 1-2 CPU cores. Go through is the authentication service. Like I mentioned previously, all the authentication and authorization is done by this component. So all the user signups, logins, password resets are handled by GoThrough. And of course, you can integrate GoThrough with many providers like Google, Facebook, Apple, Microsoft, Twitter, GitHub, Slack, Discord, and support for many others. This is a mandatory service, so you must enable it. It doesn't require that much resources, around 1 gigabyte of RAM and 1 core. Postgres is the REST API that serves your database. Meaning, in a traditional development world, you would need a development team to create APIs that provide access to the data. This is offered out of the box by Postgres, where you can basically access your database via RESTful APIs. So you can get data, you can edit the data, you can delete data by calling APIs. This is achieved by Postgres by converting all your APIs calls into SQL queries on the database. This is a mandatory component. It requires around 1 or 2 gigabytes of RAM and 1 or 2 cores. Real time. This is a WebSocket implementation, and this is very crucial when you want to notify users of changes that happen to your data. Meaning users get immediate updates of the data that changes. So you get live updates and notifications. For example, when a customer places an order or changes a reservation, you get a notification and you can set which users get or services get this notification, so you can act on it immediately. This service is optional, so you can opt in not to install it. As for resources, 1 or 2 gigabytes of RAM and 1 or 2 cores. Storage. Storage is the component that allows you to store objects on the server. As objects, you can think of files such as images, archives, audio, whatever you need. Any type of file, you can store it in Supabase. Of course, the access to this service is secured, so you can store sensitive data like customer documents, training videos, or marketing materials, or any business sensitive information. You can store it with no issue as it is secured. This service is optional and requires 1-2 gigabytes of RAM and 1 core of CPU. As for storage, it depends on how much actual files you will store, but you can start with 50 gigabytes of SSD. As an alternative, you can configure storage to delegate the actual storage of files to Amazon S3. By default, the files are stored on the same server as Supabase is installed, but as I mentioned, if you have an Amazon S3 paid subscription, you can use that to delegate the storage of the files. Studio. This is basically the UI of Supabase. It's the dashboard where you can get to see and manage all your Supabase projects. You can see and interact with your database. You can see the tables, edit tables, create new tables. You can see also the documentation of the API. In this module, you can see, of course, the analytics module, so you can see the metrics and logs of your applications and Supabase itself. This is an optional component. As for resources, 0.5 gigabyte of RAM and 1 core CPU are enough. Image proxy is an image resizing component. So if your application handles a lot of images, I recommend you have this enabled because it resizes and optimizes images on the fly. It caches the transformed images and basically reduces the storage costs by compressing images without losing quality. And of course, having your application rendering images with smaller sizes will boost your application speed and overall performance. This is an optional, but like I said, if your application handles a lot of images, I recommend turning this on. As system resources, you can expect this component to take between half and 1 gigabyte of RAM and 1 CPU core. Edge runtime. This is the serverless function component. Similar to AWS Lambda or Vercel Edge functions, you can quickly develop functionalities without having to develop separate backend logic. So basically, in the traditional world, you would need a development team to create the application servers that would actually first host your code, your logic, then you need to deploy it, and then you would need to access the code the functionality that you created. This is automatically done by Edge runtime, so you can only basically focus on the business logic. This is an optional service. On a single node, you would need between half or 1 gigabyte of RAM and 1 CPU core. I say on a single node because usually Edge runtime should be deployed to multiple nodes that are closer to your clients. Because, for example, if you have a large user base, many clients that are, for example, in Europe and in US, then ideally you would need to have at least one server node in US and one in Europe. So basically these functions can be quickly accessed by the users that are close to the nodes. Now, if you have more than 3 geographic locations to manage, then managing by yourself these separate nodes, you may need additional developers to handle this. If you have available DevOps that they can manage this for you, then it's no problem. But if you don't have, I then recommend to go for the paid Supabase Cloud subscription where they manage this for you. Analytics. Analytics is the Supabase section that you will see how Supabase performs and how users are interacting with your application. You can create, of course, customizable dashboards, and you can see metrics useful for developers as well, and also for non-technical users such as business analysts or product owners to see exactly how customers use your services. This is an optional service. As resources, expect anywhere around 2 to 4 gigabytes of RAM and 1 to 2 CPU cores. Now, I have to mention here 2 things. Analytics comes pre-configured with Logflare. Logflare is the system that actually stores the logs. The default Supabase configuration comes by using Logflare with its same PostgreDB instance. So basically, all the production data you have for your application and all the logs will be stored on the same database instance. You can configure the analytics service to use Google's BigQuery service, so you can keep the production data separate to the observability data, which is a very good practice for production setups. Because, for example, if your main database instance holding the production data somehow by any reason is having troubles, either is down or performs very slow, then having the metrics data managed by the same DB instance, it will be hardly, if not impossible, to actually see what was causing the issue in the first place. Meaning you will have a single point of failure for both production data and logging data. So it will be sometimes, depending on the overload on the main DB instance, to actually see and debug what caused the issue in the first place, because your logging data wasn't stored in the DB because the DB was busy. Vector. Vector is the log collection system. This is a more technical component. It basically scrapes the Docker containers with all the Supabase's modules and forwards these logs to the Logflare application. This is an optional service. As resources, half of gigabyte of RAM and 1 to 2 cores are enough. Meta is a very small component, but I will mention it because up until now, all the services that I mentioned, you will see them in the Docker Compose file that we'll configure, and you will see also Meta as a separate service in the Docker Compose file. It would be good to know what is that about and why it's good to have it installed. Basically, this Meta module just handles the DB metadata, meaning it handles information about tables, columns, roles, and so on. So if you want to deploy applications where you can create dynamically tables or modify columns, you would need this module. But this is also a core component for the studio, because in the studio you won't be able to see the tables, you won't be able to create new tables and edit columns, constraints, and roles. So I would recommend have it installed, but you can also not install it if you don't plan to manage your DB from the studio interface. Now, in terms of system resources for all components combined, I have here two cases. If you want to have all services running, then expect for RAM around 12 to 16 gigabytes and 8 to 10 CPU cores and at least 200 gigabytes of storage. If you only opt in to host the essential services like the database, the API, the authentication, and the API module, then expect 8 gigabytes of RAM, 6 CPU cores, and at least 100 gigabytes of storage. Now, what I usually use and recommend as minimum for any SMB, of course, the database with its supervisor to have the connection manager. You have the API gateway, you have authentication, you have the REST API, the studio, and here, as I mentioned, enable also Meta to easily manage the database from the interface. And the analytics, of course, with the vector, which collects the logs. Otherwise, without the vector, you will see nothing in the analytics dashboards. For this configuration, I would recommend 16 gigabytes of RAM, 8 CPU cores, and at least 100 gigabytes of storage. This is a very good starting point, and it should cope with no problem with medium load for any small to medium business application. Now, where can you deploy Supabase? From my experience, I recommend using hetzner.com. Here you have some examples for their pricing models. So for 8 cores of CPU, 16 gigabytes of RAM and 240 gigabytes of storage, you pay for a server in Europe around $28 per month and around 34 in US. Of course, if you don't keep your server online all the time, you are billed per hour, but mostly you will have the server running non-stop. And even for very heavy loads, then you can use 16 CPU cores, 32 gigabytes of RAM and 360 gigabytes of storage. Then you will pay around $60 in Europe and 66 in US. Now be very careful of the cloud provider that you choose. I would stay away from Replit, Render, DigitalOcean and Railway, because in terms of compute resources, which actually you need for Supabase, they charge a lot more than Hetzner. So Hetzner is a very good option as it offers the best performance and cost ratio. Now, just for you to have an understanding why am I saying this, I made a comparison between Hetzner and these other cloud providers, where you can see clearly the price difference. Now, if you want for me to make a separate video comparing these cloud providers, including also AWS and Google and maybe Microsoft, please let me know. But for the moment, you have here an overview of what these providers charge for the compute, and that's why I'm recommending you to use Hetzner. It's the cloud provider that I use also for my own services. Okay, so enough with theory. Let's switch to some hands-on installation. So on the next parts, we will focus on creating the cloud server on Hetzner, connecting to it via SSH, getting the Docker files from Supabase Git repository, configuring the Docker for Supabase, meaning we will configure the Docker Compose and environment files, and then we'll set up Nginx on the server to easily secure and manage the Supabase server. So now let's start to create the server on Hetzner. So first of all, you need to open up an account with Hetzner, and as a heads up, after you open the account, they will email you asking for additional documents like passport and location of your business if you open up for a business account, or your current residential address if you open as an individual. But make sure to watch your email for that notification. You need to provide those documents, and this process usually takes 1 or 2 working days. And once you log into the Hetzner console, you need to open up a new project. Click here, put a name. We will say, for example, Supabase Europe. Click on Add Project. Then enter in the project, click on Resource, click on Servers, and here we have the page to create the server. So depending on where your users are located, you should create a server that is closest to your most users. In my case, I will create for the US East Coast, and as image type we will click on the Apps tab and we will select Docker, because this image comes pre-installed with Docker and is an Ubuntu Linux distribution. On the type of CPUs, we will use a shared CPU instance. We will select the Intel architecture, and as I mentioned, as a minimum I would go for this configuration. On the networking section, I would leave, of course, both options selected to have IP4 and 6 versions. And now here we need to specify the SSH keys to be able to connect to the server remotely and securely. For this, we will need to first create an SSH key, and we will do that by opening the command prompt. Now, to create the SSH key, the command is the same for both Unix and Windows. And to create that, we have this command. And don't worry, all the commands and all the details will be detailed in my blog post, and I put that in the video description. So basically, this calls the SSH keygen to create a new key with type add, which is a better and newer and much more secure version than RSA. You can use RSA if you like, but this one is more secure. And as a comment, you can put any identifier for this key, so you can easily distinguish in case you have multiple keys. In my case, I will put Supabase head. Enter. Now I need to specify which file and which path I want this file to be created. Since I already have this key already created, I will specify a new one. I will also put it in the SSH folder, as all the keys should be placed here. I will put Supabase. As for passphrase, which is basically the password that you'll have to enter every time you use this key, you can either leave it blank, but for security reasons, I would recommend setting up a strong password. We have to re-enter it. Okay, so now it said that the key was created in the folder and file we mentioned. And if we go to the folder, we would see now these two files created. One is the public key and one is the private key. The public key is the one that we will put in the configuration of the Hetzner Cloud server. So now we need to take the content of the key. We need to copy everything, but when you copy everything, please make sure not to use Ctrl A and then Ctrl C, because you will also copy this new line character, which is not okay for the SSH key. We don't need this new line character, especially this one as coming from Windows. It will be interpreted wrongly on the server, so the key won't work. So to make sure we have no problem, we will select by hand everything up until here. So the last character should be Y in this case. And I will just copy it and go to my console and put here the SSH key. Click on Add SSH Key. We will paste it. Here the name was already taken out from the key. You can click here as set as default key in case this is your first one. I will not click mine because I already have another one. And add SSH key. Now for the volumes, we have enough storage. We don't need to add other ones. For the firewall, I would recommend setting up a firewall. Where we will specify and give access for SSH, so we can be able to connect to the server, for port 80 to be able to access the Supabase Studio dashboard, and of course for HTTPS, because with Nginx we will redirect all HTTP traffic to HTTPS So we click on create firewall. So what we have here is the port 22. This is okay because we need it for SSH access. The next one we'll add for, let's say, yes, we need TCP. We will put 80, and we need to add another TCP port of HTTPS. So now we have the three rules: inbound rules, meaning all the inbound traffic will be allowed only for these ports. All the outbound rules will have it allowed because we don't need any restrictions for now. And we click on create firewall. Now we need to assign this to our server. So you click on the servers. So unfortunately it didn't create yet the server, so we'll do it again. So I need for this apps docker we set Intel, this, the SSH key will select it from here, no volumes, select the firewall that we created. And for the backups, I also recommend you to enable. You will pay like 20% of the server price, but you would get a lot of backup, meaning you will get 7 daily backups per server, and these backups are created and deleted automatically for you. So basically you will have each day for the last 7 days one backup that is done automatically, and you can use any of these backups to roll back your server in case something wrong happens. And also you have up to 30 manual backups that you can create at certain points in time. Meaning, for example, when we create our Supabase configuration on the server, we can create, for example, a manual snapshot. We can call it like V1 with Supabase from 0. And then in case something happens, we can roll back our server to this backup, or we can create a new server with this snapshot, and all the contents of the previous server will be automatically taken from there. And later on we can install other services, like for example N8N or whatever applications custom that we want, and create another manual snapshot like V2, Supabase and N8N. And then this snapshot will be there forever, nobody will delete it, and you can create new servers from it and restore your existing server to this snapshot. So 20% is a low price that you will be willing to pay just for your peace of mind and having your data backed up. Placement groups, no label, no cloud config. As a name, I don't know, you can put here any identifier you need. And here we have the total payment. So you have the server, you have the 20% for the backup, and you pay 60 cents for your IP. And click on create and buy. And now the server is being started, and the IP address is going to be allocated with your server. Now the next step is to allocate this IP to a name. You can use only the IP to connect and reference your server, but it's not very user-friendly. You may not remember this name, and if you plan on delivering this solution to your clients, it will be not very professional. So we need to assign a name to this IP. This allocation between the IP and the name, we can do it on the DNS registrar. DNS registrar usually is the site name provider that is either GoDaddy, Namecheap, or whatever provider you chose to buy your domain. For my site, I use SiteGround. and I will go to the section where can I manage my domains. In my case is here. I click on manage, and I will use this domain and click on settings. And basically what we will need to do here is to create a type A record with the new IP. So we will click here, create new. Make sure that we are on type A, and as a name we will need to put any prefix we want. We can use Supabase, and the whole name will be supabase.our domain. And for the IP address, we will need to copy the IP from Hetzner, paste it, and click on create. Now we have a confirmation that the record of type A is created, so now we can use this name instead of the IP. Okay, so now you have created one DNS record for the Supabase domain. Now go ahead and repeat the same steps, and this time you will create another record, also of type A, pointing to the same IP address, but with a value of studio.supabase. So basically this will be a subdomain of the Supabase domain. This will be specifically for the studio, meaning for the dashboard. So we are aiming to have two DNS domains, one for studio and one for everything else, meaning all the other Supabase services that are accessible mainly via API. So why this separation? Because it is more simple and less complicated and less confusing to have security and configuration files separate for the studio and everything else. To the point, in Nginx, when we will do the security and performance configuration for the studio and the API, it will be much more easier to have two separate configuration files. If we put all the configuration in one big file, it will be very confusing for us to see which rules will be applied by Nginx, because Nginx treats the configuration on the same file on a hierarchy basis. So it is very easy to get confused by the configuration if you have a big and like spaghetti type of configuration. So that's why I recommend having these two separate domains, and each separate domain will be managed by its own configuration file in Nginx. Okay, so go ahead and create this new DNS record. So now let's try and connect to our server. For this we will use again SSH command. It is the same for both Linux and Windows, and the command is like this. So the normal command would be SSH username, we will use root, and we specify supabase at ibisacademy.co. This is what you need to use, but since I used another key, not the default one, because this command uses the default key, I need to specify another key that will be used with this connection. So I do that by specifying -i, and here I will need to specify my key, which is here, and click enter. Okay, so the problem was that I put @ so I need to specify just the dot. And since this is my first connection to this server, it will ask me if this is a known server or not. I will say yes. Now I need to specify the password we set. And that's it. Now we are being connected to the server. And now we are in the root folder, since we are connected to the root. And we can now check out the Supabase Git repository to fetch the Docker files that we need for Supabase. Now we need to take the Supabase repo address and clone it. So Supabase is hosted on this address, and we can get the full URL from here. Click on code and then copy URL to clipboard. And we need to clone it on our server. And either you can clone it in the root folder or create a separate folder. I usually prefer to have it in a separate folder. So I will go to the root folder and I will create a new directory with git repos. And I will go into this folder, and now I will clone the Supabase git repository here. I will just enter git clone and the address I just copied. Again, don't worry, all the commands and every details I specify will be in the blog post in the description. And now it will pull all the objects from GitHub to our server. Now, as this may take some time, usually the Git repository contains other files than the Docker ones that we are interested in. So basically we need only the Docker folder from this repository that has the Docker compose and the env file that we need to configure. And of course it has some volumes and some files to upgrade and configure the Docker containers. So once you have this on your server, you can choose to delete all the other files except the ones from the Docker folder, or use git ignore to ignore the other folders as well. It is up to you. Okay, so now we have here the new folder created for our new Supabase Git repo. Now let's enter the Docker folder and list all the files. And like I said previously, we are interested in the Docker compose YAML file and the .env.example file. The .env.example file is, as the name suggests, a file created by the Supabase team with all the required environment variables that we need, and we just need to update our own values. Now, going forward with the strategy of syncing with the remote Supabase Git repo, I would suggest to create new files altogether, copies of the Docker compose and the .env files, because in this way we can pull new changes from the remote Supabase repo and from time to time make a difference between what we currently have and what the Supabase team changed in the meanwhile. And like I said, we are only interested in the Docker folder. So basically we will monitor only the changes within the Docker folder. All the other changes we can ignore as it does not affect us in any way. Creating these new separate files just for our use case, it would be much more easier for us to pull new changes and to make comparisons to what was changed in the meanwhile. For simplicity, to edit and create these new files, being on Windows, I'll be using WinSCP. It's a free tool that you can use by yourself. You can also, of course, choose to manage these files in the terminal window as you wish, using either vi or cat commands or any other tools that you wish. Like I said, this is running Ubuntu, so you can choose any text editor for this Linux distribution. So here I have WinSCP. I have already connected to the same server, Supabase.env aibizacademy.co. Again, connected with the root user, and I am in the Supabase Docker folder. And like I said, I will be making a copy of the Docker compose file. Right click, duplicate, and I will add a suffix like Hetzner. And now I have the file, and I will edit the file with my favorite text editor on Windows, Notepad++. And here is the file. Now let's go over the tags in the Docker Compose file. We have the name with Supabase as identifier. This is basically the name of the grouping of where all the services will appear in the Docker application. And the services tag holds all our services identified by a name and all the other properties like the container name if you choose to have it a name, the image, health checks, and other environment properties. Now we have here all the services provided by Supabase. So the default Docker Compose file from the Supabase Git repo comes filled with all the available Docker containers. So our job here is to simply remove what services we don't want to use. You can either choose to remove by deleting the tag with the service you don't want, or you can choose to comment the whole service section using as prefix the hash symbol. I prefer to delete the whole section to have a very clean and clearer file. Now going forward, as you can see in the presentation section of our video, I try to reference how the services are also being named here in a Docker Compose file, so it would be easier for you to identify which service it is. And now for our use case, let's see and disable what services we will not be using. But before that, I want to make an important recommendation regarding the image versions that you will be using in your Supabase production setup. You should use only final versions of the images. Why is that? Because I've seen many YouTube tutorials instructing to use here the latest version. The latest version is used just for development purposes and for testing, and that's it. Do not use the latest tags for production. What you would do in case you would see the Supabase team added a new version, like I said previously, you from time to time have to pull changes from the Git Supabase repo and monitor only the changes in the Docker folder. And if they make any changes to the image versions for the services that you are using, this is what I recommend you to do. First, you need to test the new image. Every time you change the image, you must test it before going with it into production. You can do that by simply using also the backups done automatically by Hetzner, using especially the daily automatic backups. Meaning you will create a new server instance starting off by the latest daily image that you have for your existing server. And in that server, you go and modify for the respective service that has now a new version. You put that version and you make all the tests to make sure that everything is working as before. Also, ideally, the Supabase team would have written also a migration guide on how to exactly migrate to the new image version. Meaning what types of files you may need to add in the volumes folder, within the Docker folder, or maybe you need to add some new environment properties, they should have written this in the migration guide. If they don't provide one, that means that everything should go out of the box, so you should just update the new version and it should work bolt on. But before going that, I would strongly recommend to test it just like I said. Once everything works okay on the newly created test server, you can simply delete that test server and then go to your production server, update with the new version, restart Docker service, and you should be good to go. Now let's see which services will disable and which not. For the studio, I said we need the studio because I want the user interface to manage my Supabase services and my applications. Kong, of course, is the API gateway, so we are going to need it, and of course it's mandatory, so we cannot disable it. Auth is the go through, and we'll be using it, of course, and it's mandatory. Postgres, we'll be using it's mandatory. Now, this is the real time. Like I previously said, if you want to update your clients in real time with the changes you've done to your services, especially on the database, then I would recommend you to use and enable the real-time service. In my case, I won't be using it, so I will just delete the real-time tag like this. Going forward, the storage. I won't be doing any applications where I need to store a large number of files, so again I will disable it. Same for the image proxy. I won't be developing any applications that manage files. The meta we need it because we want to have shown for us the DB schema and to be able to create and manage DB objects within the studio. The functions are the edge functions, like I previously said, like the AWS Lambda. As I'm having a strong background in development, I usually prefer to have a separate server where I host certain functionalities. But to get started, where you have maybe limited development experience and you have, let's say, small to medium complex functionalities to add, then I would recommend for you to use the functions service. For my case, I will delete it. The analytics, like I said, I want to have it. I will leave it at is. The DB, of course, is the Postgres SQL database. Again, you see, here we are referencing a final version for the DB. The vector, of course, this will collect the logs from the Docker containers and will forward them to the log storage. In our case, it would be a Logflare. And the supervisor is the database puller, and I will leave this enabled because my applications will require multiple concurrent users. Volumes, you'll leave it as is. And that's it. So basically, this is my Docker Compose configuration file with all the services that I need. Going forward, if, for example, I change my mind and I need to add a new service, then I just come here and add the service within my services tag, and I should be ready to go. Of course, as with any new service that you add, you must make sure that you have also the right environment variables defined in the .env file. Now let's save the file and we'll continue on creating the environment file. So as we said, I will make a copy of this file and I will name it that's not. And I will edit with Notepad++. Okay, so here we have all the environment variables required for all the services, and we have some default dummy data set by the Supabase team. So we need to put our own production values. I'll be going through all of the properties so you know exactly what they mean, where they are used, and what values you must put and which values you must avoid. So we have the Postgres password. This is, as the name suggests, the password for our DB. I would highly suggest setting up a strong password, at least 32 characters, 64 ideally, and going forward for values for other keys as well. You should be using values from this pattern, meaning you should put uppercase character, lowercase, and numbers. Especially for the DB password, don't use the @ symbol, as this is usually used as a separator between the DB user and the DB connection string, and having in the value of the DB password will cause you a lot of troubles. So please don't use the @ character. I also recommend you to not use any special characters because the value is parsed as string between services and some specific characters may break the values. I will set here some random characters, lowercase, uppercase, numbers. Here we have 58 characters. Maybe we can go a little bit more. That's it. So we have 72 characters, should be fine. The JWT secret. As the name suggests, this is a secret used to sign and verify tokens across Supabase services. And also to generate the anonymous key and the service role key, we will be using the Supabase self-hosting guide, where on that page we will find some helpers for us to generate the values for these 3 keys. So the Supabase self-hosting guide, you can find it on this address. Don't worry, I will put the link in the blog post in the description, like all the information I mentioned so far. And we must go to the Generate API Keys section. And here we have the JWT secret with both key types, the anonymous key and the service role key. You can use the default value provided here because it is changed every time we update the page. I can also recommend you to override it and to make it a little bit more secure by adding more characters of the same pattern as before, lowercase, uppercase, and numbers. And let's say I will be using this value for the secret, copy it and put it here. Now let's generate the value for the anonymous key. The anonymous key is JSON Web Token, is of course signed by the JWT secret key, and it's meant to be used by unauthenticated or anonymous users, hence the name, like your front-end web or mobile apps before a user signs in. Now, to generate the values for the anonymous and the service key, we need to specify some properties having this JSON structure. We have to specify the role, the issuer, issued at, the date and the time when the token was issued, and when it will expire. So for the anonymous key, we have here the role unknown, which is okay. As issuer, we must specify our own server that we have been using so far. In my case, is supabase.aibizacademy.co. And these are Unix timestamps. And usually for these types of operations, I use this site where I have here a section that I can specify a date in human format. Let's say I would want to have my issue date on the 12th, not on the 13th. For me, the 13 is not a lucky number. So let's say I would want it at the middle of the day. in GMT and click on human date timestamp. We need the value without the milliseconds, just the seconds. I will copy this value and put it here. And for the expiration, usually I recommend having a window of 3 months. This is the security standard used in production. Every 3 months you have to rotate all of your secrets, but do create some reminders for you to change all of these secrets before they expire. So I will put here after 3 months. It automatically generated the new value. I will copy it and put it as the expiration. Now we are good to go with the value for the anonymous key and click on generate JWT. Copy the value and then paste it in our file. And we will do the same for the service role key. I will just copy these values to reuse them next. So we need to change here the service key. And when we change the service key, all the other properties were reset. So that's why I copied them to have the issuer for our DNS server and the same values for the dates. And I will click on generate token, copy the value and go to my environment file. And this is it. You can of course generate these tokens as you wish. You can generate them via code. They are just regular JSON Web Tokens having that structure, as long as you specify the structure with the appropriate roles, like service role for the service key and anon for the anonymous key, you should be fine. For example, you can use the JSON Web Token library in Node.js or any other libraries you prefer. Now for the dashboard username and dashboard password, these are used to protect the Kong admin dashboard. So ideally you should override the values, don't leave the default ones. So let's say my and for the password, I will set a strong password. That should be good enough. And a quick and very important note here. I saw there are some versions of the Studio container that do not ask for the username and password when you try to access the Studio. And you can overcome this security bug by adding this new parameter here, studio_secure equals true, in hope that when you will try to access the dashboard, it will prompt you for the username and the password. If even with this parameter it does not ask for the credentials, then the only option you have is to create a username and password and to enforce those on Nginx level. So basically you can define username and password and you delegate Nginx to ask for that username and password when you try to access the Studio. The exact steps on how to do that and to define the username and password and configure Nginx for this specific use case, you can check the link in the description. The secret key base is used by the supervisor, the connection puller, to sign and encrypt cookies and session data within its internal web server. For this property, make sure to set a value of exactly 64 characters. This is mandatory. Not more nor less, but 64 characters. Use the same pattern. Again, ideally you should be using a randomizer tool to have as random characters as possible. So now we have set 64 characters and we are good to go. The vault encryption key, also used by supervisor to securely encrypt and decrypt secrets that are stored in its internal vault system. As for the value for this property, we should have exactly 32 characters. So now we have 32 characters. The following properties are for the database. We have the host, the DB instance, and the port. As long as you don't use this port already on your server by either an application or another Postgres instance, you should leave the default value as it is. The following are values for the supervisor, for the DB pooler. The only thing we have to change is the pooler tenant ID. This property is used in a multi-tenant setup. Think of tenants as separate users, customers, or projects. This is an identifier used by supervisor to distinguish your tenant and use the appropriate supervisor configuration. We put here my listener tenant. Next section is for the Kong API proxy. We have here the default ports for HTTP and HTTPS. We can leave them as default. The next property is for the Postgres service. Here we are listing all the schemas that we want to make available for the Postgres service. Don't worry, any data from these schemas won't be accessible to the internet because all the requests made through the Postgres service will have to be authorized and authenticated. But just as a security measure, you should put here only the DB schemas that you actually intend to serve via the Postgres service. Now let's move on to the site URL property, which is used at user-facing redirections and email links. Think of email confirmations, password recovery emails, magic links. So every time you get an email of this type, the links within the email will be created using this as the base URL. And of course here we need to set our domain. And always we will be using HTTPS for our production environment. We'll configure this in our last section of the video where we are going to figure it with Nginx. Also the same for the API external URL, which is used internally by gothrough to construct URLs that call other Supabase services. But let's add the same, of course, with HTTPS and leave the port as is. The next properties are for the mail configuration. So in case you want to send any type of mails, especially the ones for the account management, like I just previously mentioned, you need to set up your email server properties here. Let's switch to the studio configuration. Here you can set some default names for your organization and project. This is up to you how you set them. You can set your values, like for a specific client who you may deploy Supabase to, or a specific project. It is up to you. Here is the studio port. You can of course configure if you have other applications running on your host server. The Supabase public URL is the public facing URL of your Supabase services, especially the studio. Again, here we will put the HTTPS address with our domain and the 8000 port. This is a property for the image proxy service. As we didn't enable the image proxy, this property has no effect, as with other properties as well. You can set any properties here with any values, but if those properties are used by a service that you didn't enable in the Docker Compose file, they will have no effect, they will not be used. The OpenAI API key is in case you want to have an AI assistant in the SQL editor of Studio. You'll put your key here. This is a key for the Edge functions. Again, if you have enabled the Edge runtime Docker service, I would recommend setting here the true value because it provides an extra layer of security, as only requests signed by your token will be allowed to call your functions. Of course, this prevents attackers from invoking functions with forged or invalid tokens and thus securing access to your backend logic. And the following properties are related to the analytics service, the Logflare Logger backend API key. Since, as I mentioned before, we will be hosting ourselves the log server with Logflare, but of course you have the option to delegate the logs storage to Google's BigQuery service via these properties. Let's start with the Logflare configuration. Since we are self-hosting Logflare, these properties can be set by ourselves with any value. For the Logflare API key, we can also specify our own value, no issue. It is perfectly fine to use the same value as before. Another quick update. So right before I published this video, I saw that Supabase issued some updates, and in the new version that they just published, I saw that they did some modifications to the logs section, basically the section affected by Logflare. So what was changed? They removed these two parameters and they added these two new ones, Logflare Public Access Token and Logflare Private Access Token. So basically, you can ignore the previous properties, leave these new ones, and for the values, I recommend setting 32 long characters for both tokens, but as they say, please provide different values for these two tokens. This is Docker internal configuration, which should run perfectly fine on our Ubuntu powered remote server. And as I mentioned, if you are using BigQuery service to host your logs, a service that you pay separately to Google, you have to configure these properties because they are used to identify and authenticate to your proper BigQuery service. And that's it for the environment file. Just make sure to save it. So we have reached the last part of our video. We will make sure everything is set up properly for a production setup. Meaning, first we must make sure that we have all the required ports exposed by the Docker containers. And then we'll have to secure everything with Nginx on the cloud server. So let's double check our configuration. What we must check is for the Kong, for the API, we must make sure that the required ports are open, meaning the ports for HTTP and HTTPS. So we have them configured here. First, it will be taken from the environment file we set up. If not, the default standard ports will be used and exposed outside to the cloud server. And just as reference, the first part before the colon is the port on the host machine, and after the colon is the port on the container. So everything is okay with the API gateway. For the studio, we must make sure that the port 3000 is exposed, and now it is not exposed, so we must add the port section to the studio service. we are doing it like this, so 3000 and 3000. Now let's check the ports for the supervisor are exposed in case we want our database to be accessible for other applications, not only the Supabase. So if you are hosting other applications either on your server or on another server and you want the DB to be accessible as a standalone Postgres DB, we must expose the ports, either the default Postgres port for a direct connection to the database, or the port used for connecting to the database via the supervisor, meaning the connection puller. So they are both exposed, so we are good to go. Just make sure to save the file. Okay, so now let's connect to our server and set up Nginx. Let's connect with SSH. I will be using my own separate key. I used this file and we'll be connecting with root at supabase.aibizacademy.com. Specify the passphrase and we are on the server. Now I will issue all the required commands to set up Nginx, but rest assured I will be listing all the commands as well in the blog post from the description. So first let's update our available packages list to their latest version. We do that with apt update. And now we need to install Nginx with this command, apt install nginx -y to automatically answer yes to any prompt it may give us. So I had already installed Nginx to the latest version. Now we must enable and start Nginx. We enable with this command and then we start with this command. The next part would be related to the SSH communication, meaning we need to properly encrypt the SSH traffic, and for that we must generate an SSH certificate. We can do that with certbot, which we can install with this command. Yes. Next, we need to specify certbot to generate an SSL certificate for our supabase.aibizacademy.co server and to tell it that we need to also configure Nginx to use this certificate that it will generate. And we do that by running this command. We must, and I recommend setting up your email address to receive notifications in case of renewals or failures or security notices. I will just put here a dummy email address, but you would be putting your own. Accept the terms of service. As you wish to share your email, I would say no. Okay, so now it says that it generated a certificate located at this path and it generated it for this domain and made the Nginx configuration for this site at this file as well. Now going forward, we must make sure to save the path to the public and private keys. So I will just copy this and I will paste them just to have them here. That command created the SSL certificate for us for 90 days and certbot will attempt to renew the certificate twice per day and it will only renew if the certificate is within 30 days of expiring. We can double check this with this command. If you have something on your screen that displays a time, it means that the update service is running. Additionally, just to make sure that we will restart Nginx after the SSL certificate is renewed, we can add a hook to Nginx where we will restart Nginx. To do that, we'll need to create a script in the renewal hooks like this, and we need just to paste this command that will basically say, okay, restart Nginx. I will exit, Ctrl X, and I will save to the same file, enter. And now we must make that file that we just created here executable. So it must change the mode of this file with X to be executable. Okay, so now ideally we must start to create from scratch the Nginx configuration for our Supabase deployment. We can do that with creating this new file into the sites available subfolder of Nginx. This tells what sites we are protecting with Nginx, and in the sites available folder will be like all the sites that we can secure, and afterwards we can choose which of them to enable. But first we must define them here in the sites available folder. And now we have to paste here this block of text. And don't worry, the text and all other comments that I went through the video and some other recommendations that I have for you, all of them are accessible in the resources from the description. So basically here we tell Nginx to listen on port 80, the standard HTTP port, on this domain. And here we only have a redirect to HTTPS, to basically to this server block that handles HTTPS. So in essence, this block doesn't do much, just forwards the HTTP traffic to HTTPS. And here we have the server name, the same as here, because we listen at the same address. Here are the SSL certificates that we generated with Certbot previously. So these are the paths that we copied previously. And here we have a location block that basically says that on the root path on this address, we will handle all the traffic here in this location block. Here are some headers that I recommend you setting them up. And here the main functionality of this block is to forward all the HTTPS traffic to this address internally. As you remember, this is the port that we exposed in the Kong Docker service. So basically all the HTTPS traffic coming via this path to our server at Supabase will be forwarded to the Kong API gateway of Supabase. And as you remember, Kong is basically a proxy, and based on the locations or the paths that are passed to the slash, Kong will forward them to the responsible Docker services. We will see that later when I will show you the links that you can access and construct to call the Supabase services. And here at the end, I just put some log files that you can inspect later for access and in case of errors. So now we go ahead and save this file. Ctrl X. Yes, we want to save the file. And now let's go ahead and create the Nginx configuration file for the studio. So we create another file here in the sites available folder named studio.supabase. And here we paste this text. And here, as previously, we have two server blocks, one that listens on HTTP port and 80 and does the same redirect to HTTPS that is handled by this server block that listens on HTTPS. The same server name. The certificates, here of course we have the same certificate file that we generated previously. Even here we are referencing the Studio subdomain. We will be using of course the same certificates as it handles both our main Supabase domain and our Studio subdomain. And here we have the same, the location block that forwards all the traffic to our Studio Docker container that, as you remembered, we configured it to listen on port 3000 on the Docker Compose file. And here are the same headers that I recommend you set and the log files. So that's it for the Studio configuration, and now save the file. Now the next action would be to remove the default configuration done by Certbot, because we only want to apply our own config, and we do that by removing the link on the sites enabled for the default configuration done by Certbot, like this. And now, after we created the two configuration files, now we must enable them, and we do that by creating a link to the files from the sites available folder into the sites enabled folder of Nginx. This is how Nginx is configured. So we do that first for the Supabase configuration file, and then we repeat the same command for the studio.supabase configuration file. And now we see that in this sites enabled folder, we have these two links created to our configuration files from the sites available. Now, to make sure everything is fine with our Nginx configuration, we must test it with this command. And if everything is fine, you should get test is successful and syntax is okay. Now just reload Nginx with this command, and we still have to make an adjustment regarding the Certbot certificate renewal, because as you remember, the Certbot daemon will connect to the internet and download the new SSL certificate when the existing one will expire. To do that, we'll have to make a small change in the Nginx configuration file. So let's open the configuration, and we need to add a new location block into the server entry of port 80, because this will happen on the normal HTTP connection. And we must add these lines of code. So basically we tell the server that it is okay to allow traffic on port 80 to only this path on the server. So now we Ctrl X, save the file, and we need to create those two directories, those two folders on the server, so the Certbot renewal service will work with no problem. So we need to create this folder that we specified in the Nginx configuration, and also it requires this well-known subfolder as well. And as by default, all the files from the var/www folder are accessed usually by the www/data user. So let's change also the owner, because now we were with root. So we need to change the owner for all the subfolders of this Certbot folder as well. And now we just make sure, test it to see that everything is okay, and reload it. Okay, so here are most of the links that you will be using. Of course, the dashboard, the studio, we can access via this link, studio.supabase. This is the subdomain that we created and configured in Nginx. Of course, double check and make sure that you are being asked for the username and password. If not, then you need, again I emphasize, you need to create and enforce the username and password in the Nginx configuration. You can check that in the resource in the description. For the other services, for Postgres, we have this base path, rest/v1/, and after that you will have to, and for the other services as well, you have to compose the URL with the parameters that are required by the services. But these are the base paths that you must access. For the go through, for the authentication service, it's /auth/v1/. For the storage is storage, real-time, and edge functions is functions. For the DB connections, again we have this connection string with this port for the direct connection to the database. And if you want to have the connection go through the supervisor via the pooled connection manager, you can use this port. Yes, of course it doesn't work because we didn't start our Docker containers yet. So we do that by going to the Docker folder, and we need to start all the containers by specifying our own Docker Compose file and our own .env file that we created, and we do that by this command. So this command will start all our containers in detached mode, meaning this Docker Compose command will not be linked to this terminal. So once we close this terminal, our Docker containers will run with no problem. And as first time we run this Compose, the Docker will pull all the images before starting them up. Okay, so now all the Docker containers have been started, and we can check their status by the docker ps command. And here on the status, we can see the studio is up and healthy, the API gateway Kong is up and healthy, Postgres is up and healthy, as I'm guessing it doesn't have any health check, so it doesn't show any health check here. The authentication, the go through, is up and healthy. Everything is up and healthy. We have supervisor, we have the meta, Logflare, the DB, and the vector. So everything is up and running without any issues. Now let's try again to access the Studio dashboard. And success, the communication channel worked on HTTPS, and now it is asking us for the username and password that we set up for the studio. And we get those if we go to our .env file to get the username and password we set for the dashboard. So this was the username, and the password was this one. And there you have it. Now we have successfully connected to our server on HTTPS. So I can congratulate you for putting up this whole time and working setting up your Supabase instance. Everything is all set up for production. Everything is secured and properly configured. So I hope you found the tutorial helpful. Now we can also have some improvements to the Nginx configuration, which are recommended for production, meaning we must have a denial of service policy in place, cache headers for static files, rotate the Nginx log file so we don't use space with too much logs. Also, there are some default APIs that are being used by Supabase internally, and ideally we should block access to them from the public internet, and also block search engines from indexing our Supabase instance. And one server improvement that is also very important, to create a script that automatically starts the Docker containers for us at server startup. This can happen in case you normally restart the server, or the server auto restarts in case of a failure. But don't worry, all these extra steps are described in the blog post in the description. That's it for this video. I hope you learned how Supabase can serve as a solid foundation for your business' most important needs, and how to properly set it up yourself without the headaches. While this channel doesn't typically focus on detailed self-hosting setups, I'll be using Supabase as the foundation in all my upcoming videos about bringing AI into your business. I wanted to give you this overview first, so you'll have the background knowledge for what's coming next. If you're looking forward to more videos on practical AI for your business, make sure to hit that subscribe button. If this video was helpful, please hit also the like button. It really encourages me to create more content like this. I'll see you in the next one.